What's up, CoderByte? Welcome back to another data structures and algorithms video. I'm Elizabeth, and today I'm kind of tired. No, today is part 2 of our merge intervals mini series, all about the interview pattern, all about merge intervals. These are the kinds of questions where you'll get a list of intervals with start times and end times, or starts and ends, whatever that means. And the question is asking something like, where is there no overlap? Or merge the things that do overlap, that sort of thing. Today we're doing part 2, so it's going to be slightly harder than that, but just slightly. I know you can all do it. And with that, let's get into this week's problem. Okay, so let's review this pattern. Merge intervals. This pattern is all about efficient techniques to deal with overlapping intervals. Often in these sorts of problems, we're asked to find the overlapping intervals or merge intervals if they overlap, or like I said in the intro, find the spots where there are no overlapping intervals or where there are no intervals at all, that sort of thing. So let's look at an example really quick. Here's an array of intervals. So the first interval starts at 1, ends at 4, second 2, 5, third 7, 9, etc. And we would expect after merging those intervals to get one big interval, 1, 5, which encompasses these first two because they overlap, and then finally 7 and 9 because that does not overlap with anything, so we just have to take it as is. Okay, so it's a pretty simple concept in terms of like all of the patterns we've done so far. And I think the problems are also relatively simple, especially if you know how to deal with the merge intervals, how to merge them accordingly, and then kind of do as the problem asks for all of those little different pieces that make each of these problems different. But the bones for these are super similar. So I highly recommend you go over that over and over and over again. And yeah, let's keep going, see what this week's problem is all about. Oh, I'm just kidding. Let's see a number line and see a visualization of these intervals just in case you can't picture it. So here we have a number line 1 through 10. Here's our first interval 1 to 4. Here's our overlapping interval 2 to 5. You can really see it in the visualization how they overlap. And here's 7 and 9. So if we merge that, we'd expect one big interval 1 to 5 because those overlap. And then finally 7 and 9. So what's this week's problem? Given a list of jobs, each with a start time, end time, and CPU load while running, find the maximum CPU time at any time if all the jobs are running on the same machine. Okay, so let's look at an example input of what this might kind of look like when we're doing the problem. So here we have an array of jobs, and we have a few different objects, and we have each object has a start time, an end time, and a load property. And these are all just integers, right? So the start is 1, end is 4, and the load is 3. It's all integers. This we're saying is representing time in some way, and this is representing actual CPU load, again, whatever that means. So what is that what's the output for this, what's the expected output for this input in this problem? So we're going to expect to get 7. So let's see, how do we get that? So let's look at our intervals. So we have one that starts at 1 and one that ends at 4, one that starts at 2 and one that ends at 5. So these two overlap, right? So that means that if all of these jobs, and then 7 and 9 does not overlap. So if all of these jobs run on the same computer and the same machine, that means that at some point, we don't have to know this, but at some point, it's going to be probably between 2 and 4, there's going to be a total of 7, whatever measurement this is. So we can add these together, 3 and 4, because at some point in the lifetime of this machine, there's going to be a load of 7 on this machine. And we can know that because of those intervals and that those two intervals overlap. So I hope that's clear. What's going to be our approach? So our approach is actually going to be almost entirely the same as last week's problem. So if you haven't seen that video yet, I highly suggest you check it out. But this is where we kind of went through the bare bones of taking intervals and merging them down so that you at least combine the overlapping intervals. And then we can take it from there. So what's our approach here? Like last time, we're going to sort the intervals by start time. This, if you'll remember, reduces the amount of scenarios that we can possibly get when comparing two intervals, because the first interval that we're comparing is always going to have an earlier start time than the second interval. And at most, that second interval will start at the exact same time. But essentially, we can always take that start time from the first interval because we are sorting them. That's key here. Like I just said, if we reduce our scenarios such that A start is less than or equal to B start, we're left with 4 scenarios. What are those 4 scenarios? We have A and B do not overlap, A comes first, A and B overlap, B ends after A completely overlaps B, and finally A and B start at the same time, but actually B fully overlaps A. And again, this is going to be exactly the same as last week, so you'll recognize this if you saw that video. But essentially, in the 3 scenarios, B, C, and D, we merge according to different rules. What are those rules? A start, for B, we get A start and B end, right? For C, we get A start and A end because A overlaps B completely. And finally, for D, we get A start and B end because A and B have the same start. Doesn't matter which we pick, so we can pick A every single time. And then we take B, which is the later of the 2 intervals. And this can be kind of summarized into that if A and B overlap at all, and we've already sorted them, we can take the first start time of A as our C dot start, always, because we've sorted them again. And then for our end, we can always just take the maximum end between the 2 ends. So if A ends first, if A ends last, take A. If B ends last, take B, essentially. So we're going to merge these intervals according to these rules. And again, this is going to be exactly the same bones as that last algorithm we did last week. So what's the difference here? How are we going to keep track of that CPU load and the maximum CPU load? So when we combine the 2 intervals, right, if we're in a case such as B, C, or D, the only thing we also have to do is at that point when we make the new interval C, we have to add the 2 load times of the 2 intervals A and B, right? Because over that period of the merged interval, we can assume that they're running at the same time and both loads are coming into play, so we can just add them. And we can just keep track of what's the max we've seen so far after we have continued to merge all of the intervals together. And at the end of it, we'll have the one with the maximum CPU load so far. And because as we merge all of the intervals, we're also merging those CPU load times, that's how we can tell what's happening all at the same time on any given machine for this problem. So hopefully this is clear. It was hard to kind of put this into the approach in the slides, but I think it will be really easy once we code this out. So why don't we get to that? Okay, so I hope you're all used to this by now. I am in Visual Studio Code and I have a totally blank file. Let's get started with defining our function and our test cases. Okay, so let's get started with defining our function. So let's say max CPU load, right? And what are we going to do? We're going to get an array of jobs. Okay, so let's define some test cases here. And let's say max CPU load. And I'm just going to copy and paste this straight from the slides. So here we have our, intervals, again, exactly what we saw on the slides. So we're expecting that output to be 7. And then I have a couple other test cases that I have prepared that I'm going to paste in. So here's more intervals. These I left in sorted order of start time. These are not sorted. And for this one, we expect the answer to be 15 because even once we merge, oh no, those don't have to get merged. So actually none overlap in this problem, it looks like, right? 2, 4, 6, 7, 8, 12. So we just take the maximum load. Very cool. And then finally, I have one more. Console.log, CPU load. And for this one, we have 1, 4, 2, 4, 3, 6. So they actually all overlap. So we're going to add all of them, and our expected output is going to be 8 here. So I hope these kind of cases are clear how I'm getting to these outputs, what I'm expecting to see. But essentially, again, we're merging our intervals and adding our loads and seeing kind of where do we have our maximum CPU load at any given point. Okay, so we're all set there. Let's go define our function. So, like I said, I hate to, repeat, but I think this is a really, really good kind of exercise. This is going to be so similar to the problem we did last week. So, again, go back, really study the bones of this algorithm because it's all more or less the same. And if you can just pull this out of your interview toolkit when you have to do a merge interval problem, likely the problem is going to be something following the bones, and there's going to be kind of Easter eggs. Happy Easter, everyone, by the way. There's going to be kind of little bits that make it a unique problem, and that you can just modify those bones to fit your case. And even if you can't and you fail, which sometimes happens, at least you demonstrated that you know how to merge intervals and you kind of got one part of the interview problem. So really know this very well. And I think that goes for all of the interview patterns we're doing right now. If you know the bones and you can put the bones on the whiteboard when you're doing an interview, that counts for something, even if you can't take it even like further than that. If you can recognize what bucket a problem falls into and at least get started, that's a really good sign. So anyway, just food for thought here. Okay, so of course, what we're going to do first is sort our jobs. So let's say const sorted jobs equal jobs.sort. We get an A and a B. And for this one, we have starts and ends. So I think we can just do A.start minus B.start. And I think that should give us our sorted jobs. So let's just make sure console.log sorted jobs. And let's run this. Okay, sorted 268, sorted 123, sorted. Okay, cool. So we have our sorted jobs. And then, like last time, we're going to be using a stack, right? We're going to be initializing some sort of stack, and we are going to be pulling the last interval off the stack that we just looked at, comparing it to the first interval from the sorted jobs array, which we are going to be modifying both at the same time and using those two arrays together to kind of create this merged intervals array. So let's say that our first job, right, that we're looking at here is going to be sorted jobs.shift. And remember, we're taking off the beginning because we sorted it by start time ascending. So the first element will be the earliest. And then we can say that we're going to have our merged intervals, and we can just put our first job on there, right? And then, I think possibly for this approach, for this algorithm, I might just merge the intervals, and then afterwards we can kind of put in exactly the max load time, because I really want you to see that it's the same problem, like almost so close. So, there's more to do here because we want that, we want to know the CPU load of that first job, but we'll do that at the end. So let's, for right now, just focus on these, scaffolding this out. Okay, so we have our merge intervals. So let's say while our sorted jobs has length, we want to run this code inside this while loop. So, all right, so let's say our const A interval, right, what we're comparing is going to be that merged intervals. It's going to be the last merge interval we saw, which in this case is just going to be the first job off of the sorted jobs array. And then for B, we're going to take the next job that's the first in the sorted jobs. So let's say sorted jobs.shift. So now we have an A and a B. And what do we have to do? We have to check those 4 scenarios that we saw in that last slide, right? So what's the first scenario? The first scenario is that they don't overlap. We need both of them, right? So let's say if A dot or B dot end is greater than A dot, no, if B dot start is greater than A dot end, meaning that they don't overlap, right? We can say that we need both of them. So we can just say merged intervals dot push A and merged intervals dot push B and call it a day, right? So let me just say here, no overlap. We need both. Okay, so then what else could possibly happen here? So if that's not true, they overlap. So this means we have to merge, right? If we're in this else. So of course we have to make a new interval C when we're merging, right? So let's say const C right? And this is going to need a start, which is going to be a dot start, because it's sorted, we can always take that A's start time. We can take end, which is going to be, what is that going to be? I think that's going to be the math.max, right, of a dot end and b dot end, right? We just take the maximum of the two intervals ends. And then finally, our CPU load time, which we have to keep into account here, right? So this is going to be the part where we add the two CPU load times of the two different intervals, because we're combining them. And as far as we're concerned, during that time, at least at some point in that merge interval, the CPU load is going to spike such that it's the total of the two intervals combined. So what do we do here? Again, pretty straightforward. We do a dot load plus b dot load, call it a day. That's it. So now we have our new interval, right? So we can push that onto our merge intervals list here. And this is the scaffolding of the whole algorithm, right? So here we can return our merged intervals, right? This would make it look almost exactly the same as last week's problem. Now we're not returning our merged intervals for this problem, right? We're returning this thing called max CPU so far. So let's actually define that up here. Let's say, so this is the part where the algorithm gets slightly different if everyone is following along here. So let's say our max CPU so far, right? So we can say that at this point, we can just take that first job.load, because at this point, all we know is we have that one interval and or the one job, and whatever its load time is, we can initialize as the maximum we've seen so far. So what do we do with this, right? We're returning it ultimately. This is going to be the output of this algorithm. So we can do that down here, say max CPU so far. And when do we update this, right? So when do we see new load times each time? So basically what we have to do here is we've already done for each of these, if we're in the case where we don't overlap, right? That means that we've already seen A, right? A has already either been here, right? We're at the start of the list of jobs and our max CPU so far, we've initialized at A, or in the last iteration, we've already captured A's CPU load. So actually what we're doing here is we need to compare B's load to whatever we have previously, which might be the A before it. It might be from some other interval, we don't know. So here, all we have to do is we have to calculate this max CPU so far and say that that's actually now going to be equal to the maximum between the max CPU so far and B dot load, because B dot load is the one we haven't seen yet. A dot load in this case we've already seen. Again, either because it was a B at some point, or it was somehow taken into consideration, or it's the initialized one. So here's where we kind of take that into account and we compare it with our next interval. And here we do the same thing, except with C, right? So here we also reset max CPU so far to be the math.max between the max CPU so far and C.load. And the only real difference between this line and this line is that with this line, it's just one interval's value, right? The load of B. But with this line, it's actually the compared value of whatever interval we're merging. And as we continue to merge the intervals, right, that's the beauty of this algorithm and using a stack where we're just kind of constantly taking the A interval off of the top of the stack. We can continue to kind of gather all of the load times. And each time we can ask ourselves, is this addition, is this new interval and this new load time any bigger than what we've seen so far? And that's the whole thing. So before we get too excited, let's run it, but let's see if we get what we want. So here are our test cases. Let's do that. Ah, cool. Okay. Max CPU so far. Oh, so this can't be a const, duh, because we're going to be resetting it each time. So let's do a let. And let's see what we get here. So we get 7, 15, and 8. Wonderful. Okay, so that's basically the whole thing. Again, almost exactly the same as last week, except for these lines, right? So imagine in an interval that you get almost all of it except for that. Now, of course, that's the whole point of the problem. But if you get the whole, if you get the rest of it, it's kind of easier to get that last remaining piece. So that's my kind of advice for this sort of problem: is figure out what bucket the problem falls into, get your toolkit for that pattern, do it, and then go back in and kind of modify and change things slightly so that you can actually solve the problem being asked. Um, but yeah, this is a great problem because, like I said, it's the same as last week's, just slightly harder. And I think looking at the problem, you'd think, oh, what is this? This is much harder. No, it's not. It's just slightly harder. And I think that that's a really, really good exercise for everyone to do. And that's it. And that's a wrap for today. I hope everyone enjoyed this problem. I think it's a good one. So again, if you haven't seen our first video in this series, check that out. And if you haven't seen any of our other videos that we've ever made, please check them all out. I know this is a holiday weekend for people, Easter, Passover, and I'm sure there are a million other holidays going on that I'm not aware of. So happy holidays to everybody. I know the whole story of Passover is leaving Egypt, where the Jewish people were enslaved. And I think part of the reason why we continue to celebrate it a bajillion years later is because slavery didn't end when we got out of Egypt. Everyone knows that. And I think we're all continue to be enslaved to different things, no matter what. And so for me, the holiday is all about kind of breaking free of those bonds. And so look at your life, examine, what are you enslaved to right now? Is it the interview process? Break those bonds. Go crush it. Don't be in the interview slave process. Don't be tied up by these problems. Break free. So that's my little words to wrap this video up. And I hope everyone is enjoying some time off, maybe. I don't know. But keep practicing, and I will see you next week. Bye, everybody.